Chapter 3, Personality Psychology as Science, Research Methods. The study of psychology will not teach you how to read someone's mind. It will not supply you with a list of facts. It does offer research results, and you must decide for yourself whether or not they are persuasive or convincing. The study of psychology allows you to think for yourself. Psychology is a true science. It seeks knowledge, not just catalogs facts already known. Though psychology teaches the facts already known, its more important function is providing a way to find out what is not known yet. It questions, it explores, it discovers. In contrast, a physician is technically trained to use knowledge already known. A biologist, chemist, psychologist are scientifically trained for exploring the unknown. It is called research. Some fundamental points about methodology. Personality psychology emphasizes reliability, validity, and generalizability of the data or measurements or research results that it gets. All data are not created equal. Are the data reliable? Reliability is consistency, stability, repeatability. Reliability is higher with low measurement error. Reliability means that the results would be the same, would be consistent, if the test was administered again and again. If I were to give a personality test a few times to a class to determine who the friendliest students were, and the same students were determined to be the friendliest each time, then the test was reliable. If the results were different each time, and there was not repeatability or stability, then the test was unreliable. You would want measurements using a thermometer or a brain scan, etc., to be reliable or consistent. Measurement error is the effect of extraneous influences that cloud or lessen the ability to see the trait or state you are trying to measure. The less measurement error, the more reliability. If you are interested in measuring a person's current mood or state, then the fact that this person just got a traffic ticket or just won the lottery is relevant and not at all extraneous. If, however, you are interested in measuring this person's general level of emotions or a trait, then these sudden events are extraneous and a more routine day is necessary. Error variance is fluctuation of a number around its mean upon repeated measurements. Less error variance yields higher reliability. If you wanted to know the reliability of a sperm count after a vasectomy, you would be interested in knowing if there were variances depending on the time of day, or mood, or diet, or who did the counting. You would want to know the error variance, or the fluctuation of a number around its mean upon repeated measurements, due to uncontrolled influences like who was doing the counting, or the time of day, or what the person with the vasectomy had for lunch, or what kind of mood he was in. Reliability can be hampered by 4 factors. The first factor is low precision. Data collection, measurement, and recording must be done meticulously. Carelessness will reduce reliability. The second factor is the state of the participant. Is the subject sick, sad, happy, sleep-deprived? Would the subject react differently if the experimenter was a different gender? The third factor is the state of the experimenter. Is the experimenter or research assistant rested and attentive, moody, or biased? The fourth factor is the state of the environment in which the study is done. Noise, temperature, weather, powder outage. Lots of environmental factors that can conceivably vary unpredictably. To increase reliability and minimize error variance, be careful. Double-check all measurements as well as their recordings. Have others proofread the data as well. Measure something important rather than trivial, involving and engaging the participants who are interested. Use uniform procedures. Everyone connected with the research has to follow the same written protocol. Directions must be crystal clear and pointedly detailed. Use aggregation or averaging. An example of aggregation. Everyone in 3 classes, 35 students per class, was given a meter stick and told to measure the distance to a nearby school by placing the stick down and then moving the stick and placing it on the spot where the end of the stick had been before it was moved. And everyone in the classes had to keep on placing down their meter stick and count until they had reached the school. The actual distance was 1,000 meters, but the final counts ranged from 750 to over 1,200 meters. Like Thunder said in the text, the school just wouldn't stay still. Students would lose count. Plus, placing the stick back down where the end had been was not precise. The individual student measurements were not reliable since there was such a wide range of totals. However, when each of the 3 classes had their 35 scores averaged, the results were quite stable: 956, 957, and 959. There was little error variance. All the measuring errors were random and had pretty much canceled each other out. For every person who placed sticks too close together, there was another person who erred by placing sticks too far apart. For everyone who overshot the count, there was another who undershot it. The more measurement error you have, then the more measurements you need. An average or aggregation will increase reliability. The best way to increase reliability of a test is to add more test items and to make the test long enough to represent all important topics. Also, make sure the test actually covers what was taught or assigned. A second fundamental point about methodology is validity. Validity is the degree to which the results measure what they are trying to measure, predict what they are supposed to predict. In order to be valid, to measure what it is supposed to measure, a test must also be reliable or consistent. Inconsistent results cannot measure what they are trying to measure, but a reliable, consistent measure is not necessarily valid. Reliability does not guarantee validity. Results can be consistent or reliable and still not measure what they are intended to measure. They could be reliably giving the wrong answer, like a broken clock that consistently measures the time, but is only valid or correct or measures the right time twice a day. Thus, a test or measure must be reliable in order to be valid, but reliability does not guarantee validity. It may help to pair the V word validity with the V word vegetables and the R word reliability with the R word rain. You must have rain in order to have vegetables. You must have reliability to have validity. You can have rain without vegetables. You can have reliability without validity. A construct is an idea about a psychological attribute, sort of like a theory. A construct like intelligence, honesty, friendliness, sociability affects a wide range of life performances, not just test performance. Construct validation is a research strategy that gathers as many different measurements of a construct possible. So when you're looking at sociability, honesty, or intelligence, you get many different measurements. If all these different batteries of tests yield similar results, then it becomes more believable that the quality that you're interested in, sociability, honesty, or intelligence, is actually being measured. A third fundamental point about methodology is generalizability. Generalizability is a broad concept that includes both reliability and validity. Facets of generalizability include subjects, stimuli, and responses. Generalizability of subjects. What are you learning about people in general by studying a particular group of subjects? You must keep in mind three factors that may cause generalizability to fail. The first is gender bias. Only men were included in most of the studies done before the 1960s. Now females are more apt to volunteer for research on college campuses. Males do not sign up as readily. Are volunteers as representative of the general population as non-volunteers? Participants who show up for their research appointment are generally females with conventional morality. Males are more likely to be no-shows. A second factor that may cause generalizability to fail is the cohort effect, the tendency of a group of people who lived at a specific time in history to differ from people who lived earlier or later. Personality is influenced by the historical period in which one lives, so that people who lived through wars and depressions may have distinct differences from those who lived in peace and economic privilege. Research results may be limited historically. They may apply only to the groups tested and not to people in general. The results may tell us little about what people were like during other decades or centuries. The third factor that may cause generalizability to fail is ethnic diversity. Ethnic minorities need to be represented in research if generalizability to the general population is desired. If ethnic diversity is accomplished in American research, this population being represented, American and European, is only 30% of the total world population. 70% of the world population does not live in the modern, Western, capitalist, post-industrial society. Generalizability of stimuli and response are also required under generalizability. If good results were obtained from a research study, would the same success have been realized using a different stimuli or response? Anxiety was induced for a study using a certain method, a fake earthquake. If the method was changed and the subjects were warned how very important the test was before beginning, could the same level of anxiety be obtained? If the performance test or the way the anxiety was measured, if that was changed, would the same information be forthcoming? So instead of shooting baskets at the free throw line, if you changed the performance test to answering test questions or spelling words in a B, would the same information be forthcoming? Representative design is a technique to maximize the generalizability of research results. Representative design is supposed to make research more broadly relevant. It is a concept of Brunswick, and it samples across all domains that the researcher is interested in generalizing the results to. Representative design includes more than one kind of experimental manipulation. There are several different ways of producing anxiety. Representative design also includes more than one kind of behavior. There are several different ways to measure the construct of anxiety: academic tests, sports competition, biological measures of respiration and heartbeat. There are two kinds of formal research: descriptive, including correlations, and experimental, both of which have advantages and disadvantages, and both of which are useful. Descriptive research observes and describes phenomena that already exist. It measures a variable. Descriptive research answers the who, what, where, and when of behavior. Correlation is an example of descriptive research. Correlations are statistical descriptions of how closely two variables are related. They can allow for general predictions to be made, but they do not prove cause and effect. Taller people tend to weigh more than shorter people, and if you know a person's height, you are more able to predict the weight, better than you could predict it if you knew neither variable. We say the variables of height and weight are correlated, but one does not cause the other. If you gain weight, this will not cause you to grow taller, and if you lose weight, this will not cause you to grow shorter. Correlations express whether changes in one variable are accompanied by changes in another, not cause and effect. There may be a third variable unaccounted for that changes either or both of the two variables in the correlation. Some examples: the more people weigh, the higher their salaries. This is because of a third variable, age or experience. This third variable affects both weight and earnings. Another example: The greater the degree of crowding in cities, the higher the crime rate. Crowding and crime are both related to poverty, the third variable that affects both of them. Another example, the colder the winter, the greater the number of births the next fall. Other factors are involved here. People stay indoors more when it is cold outside, and they tend to engage in more snuggling and cuddling. This leads to getting something straight between them, and voila! Resultant deliveries increase 9 months later. Still another example. One study found a correlation between the number of storks of a city and the number of births. As it turns out, the city had more chimneys in which the storks could nest due to a denser population. Denser populations also have more babies. So I'm hoping I'm not disappointing anybody, but storks do not bring babies. Correlations are expressed in a decimal number called a correlation coefficient. And this number ranges from plus 1.0 to minus 1.0, or positive 1.0 to a negative 1.0. The closer to plus 1 or minus 1, the stronger the correlation, the stronger the relationship. So when you are looking for strength, you disregard the signs. You don't look at the positive sign or the negative sign, the plus or the minus. You pay attention to the absolute value, the number following the decimal. The higher the number, the stronger the correlation. So a negative 0.8 is a stronger correlation than a positive 0.6, and it denotes a stronger relationship between the two variables. The plus and minus signs show direction of the relationship. So when you're looking for direction, note the signs in the correlation coefficient. Positive correlation, two factors of a relationship vary in the same direction. They either both increase together or they both decrease together. For example, years of education and average annual earnings, calories consumed and amount of weight gained. Negative correlation have two factors of a relationship varying in the opposite direction. As one increases, the other decreases, or as one decreases, the other increases. For instance, the amount of parental sleep and the amount of nighttime infant crying, or the distance from the stage and price paid for your ticket. The less distance, the more you pay. The more distance, like in the nosebleed section, the less you pay. Experimental research goes beyond descriptive research and predictions. Some variables are held constant while others are manipulated, and the effects are carefully recorded. One group is a control group, providing a baseline to use in comparing the other groups. Changes are introduced in a controlled manner to see if a statistically significant difference occurs among the behaviors of the groups which received the treatment change as opposed to the behavior of the groups which did not. If a statistically significant difference does occur, then the differences found were not likely due to chance, but rather were due to the treatment given. Statistically significant does not necessarily mean important or valuable or useful. Type 1 error is wrongly concluding that a variable or a factor has an effect on the results when it does not. P-level says the chance of this occurring in a carefully controlled experiment is only 5%. So 95% of the time, the influence of the variable on the results is real. And only 5% of the time is this wrong. Type 2 error is deciding that a variable or factor is not influential in the results, when in fact it is. The whole experiment may have to be tightened or redesigned for the effect to show up. Significant significance levels tell little about the size of the result. They tell instead about the likelihood that certain results will occur. And significance levels are often misleading. So don't stop there, says your author, funder. He favors effect size. Effect size is more meaningful than a significance level, because it tells how much of a variable is contained within or caused by another variable. Correlation coefficients are good measures of effect size, numerical descriptions of the degree to which one variable is related to another. Correlation coefficients can be used to tell of the strength of the effect in either a descriptive or experimental study. The T statistic or F statistic in experimental studies can be directly converted into a correlation coefficient. Effect size is the best way to summarize research results. The correlation coefficient can be evaluated with the binomial effect size display by Rosenthal and Rubin. Correlation coefficients are everywhere in personality psychology research, and the BESD, the binomial effect size display, helps to explain what kind of effects are being described. it is important to really understand what a correlation means. Emphasis in statistics classes was probably on computation rather than comprehension or conceptual explanations. As for BESD, a correlation of 0 with 200 subjects involving drug and no drug means there is a 50-50 chance that the subject would be alive or dead with or without the drug. A correlation of 0.40 using the BESD gives a 30-70 chance that the subject would be dead or alive with or without the drug. Remove the decimal in the correlation coefficient of 0.40 and divide the 40 by 2, which equals 20. You add 20 to the top left of the 2 by 2 grid, and you adjust the cells to equal 100. I'm not going to ask you to compute this, but this is a verbal description that goes along with the book. Funder claims that squaring correlation coefficients to get variance explained is inappropriate. This practice yields a distorted estimation that underestimates the size of variance. Ethics includes standards that have been tightened, and research has to pass ethics board regulations. You can't do research any way that you want. There are strict standards. The way research results are used is important. You don't want to cause more harm than good. Truthfulness in science is important. Scientists may disagree in interpretation of data, but must trust the data. Those who plagiarize or lie are forever rendered non-credible. Use of deception in research with human subjects may be allowed in a very limited circumstances. You want to prevent altering natural behavior, so it may be necessary. If participants know that bystander apathy or honesty or aggression are being measured, their behavior may become altered.